So for section 4, we're going to look at amines, and amines are quite new to you. You're not come across amines before in Unit 5, but they're no more complicated than alcohol is. So for this section, we're going to be looking at what is an amine, give me a structure, give me examples. Primary, secondary, and tertiary. This is slightly different to the primary, secondary, tertiary of alcohols and haloalkanes. And then we've got two reactions that we need to cover. One is a base, one is a nucleophile. But fairly straightforward, fairly easy. Again, I've given you guys a checklist, so this should help you out with your assignments, so you have an idea of where you're up to, what you're missing. This is the best way to check it and to double check it. And what we're going to be looking at first of all is amines in general. So what we've got here is the page that I've got for amines. Don't worry, I will take you all through it. But the easiest way to think of an amine is similar to ammonia. In ammonia, we have NH3. In an amine, one of those hydrogens have been swapped out for an alkyl chain or a hydrocarbon group. So like a methane, a propane, a pentane, or something like that. And that means that they can take place in substitution reactions and other types of reactions. Now, what we need to look at is, if we look at our amines, they are actually polar molecules. There's a permanent dipole. And that comes from this nitrogen being more electronegative. And as you can see here, I've drawn a lone pair of electrons, and that's going to come into play a little bit later on. So this is our amine group, I think also known as an amino group. N is in group 5, is highly electronegative, and NH2 groups are electron withdrawing. So it pulls those electrons towards that nitrogen, meaning that R becomes slightly positive, so that carbon becomes slightly positive, meaning it's susceptible to nucleophilic attack. The lone pair on the nitrogen over here means that this amine group is also electron rich, which means it can actually act as an electron donor, and it can also accept protons and act as a base, which we're going to look at a little bit later on. NH2 is also takes part in hydrogen bonding. If you remember, it's NOF, and they take place in our hydrogen bonding. So we can see higher boiling points with our amines than we can for our alcohol groups. But again, that's not important. The nomenclature, the naming stuff for this, thankfully, it's actually quite easy. If you see an amine group, so an NH2 group in there, it's just called amine. So, for example, my 15 carbon chain is pentadeca, but because I have an amine group, it's pentadecamine. And this is an example of a primary, which I'm going to show you in a minute. And again, there's my alkane chains. So that's fairly straightforward, fairly easy. Give me an example, explain to me a little bit more about amines. Again, if you want more information, ChemGuide is a fantastic place. Please use the information on there. You might need to have a little bit more information than that. I think I've given you more information than that website has, but you can have a look around and you can probably build a small page out of this. Now, when we look at primary, secondary, and tertiary, you can see my examples look slightly different. And now, if you remember when I said before that an amine is where we have ammonia, but one of the hydrogens has been replaced by a carbon chain or carbon, that becomes a primary amine. A secondary is where another one of those hydrogens has been replaced by a carbon chain, here and here. And then a tertiary is where 3 of them have been replaced with the carbon chain. So it has no hydrogens bonded, it's just N with 3 R groups attached to it. When it comes to naming your secondary and your tertiaries, I can't think of how this comes up, and if it does, I'll explain it. But what we're looking at is, I would just make sure you have the same alkyl group on each of these nitrogens, and then we're just going to use di and tri. So if this was pentadecamine, this one would be dipentadecamine, and then this one would be tripentadecamine, where each of those would be 15 carbons long. So this should be normal, that would be amine, this would be di, and this one would be tri. And I think that's the easiest way of naming those. Now, because of those lone pairs that I've shown you here, here, and here, it means that amine can actually act as a base. This is the reaction that we're going to be looking for, and I think this is the example that I want you to use, because I think it's a bit easier to discuss. I'm going to keep it fairly simple. I'm going to give you the most of the outlines. You just need to make your own. So pick your own amine chain, and then this time you're going to pick some form of hydrogen halide. So that's a an acid. So hydrochloric acid, hydrobromic acid, one of those. That's going to be your acid. And then when it reacts, what you're going to see over here is that the lone pairs bonded with that hydrogen, and the halide has now been dissociated. And we have a positive and negative on both sides. So it's still balanced, and we're just going to keep it as this complex here, this ionic complex, and you're going to call this your chain ammonium halide. So I would have pentadecyl ammonium chloride for Cl. So that's the structure that you're going to use. So this is however many carbons that you have. You're going to have ammonium written in there because of this, and then halide right there. It could also be correct for you to just get rid of that plus and have it like that. But it might look a bit weird in your assignment, so I would just have the plus, just to make things a bit easier. I've oversimplified this quite a lot, but I think this is the easiest way for you all to grasp that. And you can see there's not much information. I just need a good example, which has been drawn correctly and named correctly. Nice and easy. Now, I mentioned before that amines can act as a nucleophile, and this is because of that lone pair there. Remember, nucleophiles are electron rich. They're also electron donors, and they're interested in points that are slightly positive. So this lone pair would be interested in this carbon right there, because that's a halogen, which means we have a delta negative halogen and a delta positive carbon. So those electron dense or electron rich nitrogens in the primary amine is interested in attacking that, and we can get some form of reaction out of that. So let me clean this up. So if I zoom out, what we actually have here is a slightly more complicated reaction, which again, I'm not going to go into the information for it. I'm not going to give you the mechanism for it because we don't need it. I just want you guys to come up with your own version of this reaction, where amine is acting as a nucleophile. We can see here before, I've got our electrophile, which is our haloalkane. So we've got our haloalkane. I would pick a carbon chain here. And then we've got our amine, and I would pick the same carbon chain there to make your life easier. So if you have a 3-carbon chain here, have a 3-carbon chain here as well. It's going to make your life much easier when you go to draw this, and when you go to draw the product. There are some conditions that we need to know, and you can see I've hidden them behind the boxes, but there are some conditions that you guys need to know. I think that's the work that you guys can do. I've already given you the reaction, so I don't mind you guys looking for conditions. And then finally, we're going to have this as our product. So the halogen from that haloalkane is going to go form an acid. And then this time, we're going to form a secondary amine. So this is our secondary amine. Remember, we need to name this the shortest stem and the longest stem. I would make it very, very easy and just make sure that they're both the same. So if I used pentadecamine and chloropentadecane, chloropentadecane over here, I would then have dipentadecamine for this. And I would draw that out with the 15 carbons on both sides. So it'd have 30 carbons in total. Remember, it needs to balance. So if you have a 3-carbon chain here and a 3-carbon chain here, and then for whatever reason you decided to do a 4-1 because you didn't watch my video, and you got a 4-1 here, you need to make sure that you've got 7 carbons there and 7 carbons on this side, which is why I would keep them both the same. It's just going to make your life a lot easier. And then you need to go find those conditions for me. And that's it. That's easy.